We're going to talk here for the next 30 minutes or so about how to start with AI, just based on some best practices, some lessons learned that I've seen in helping clients. Can also be useful if you've already started down that path and you're wondering things like, hey, what else can we do with our data? Or what are some, sort of potential gotchas or things to keep on the lookout for? Okay. So one thing that I found helpful is to just talk about what we mean when we speak of artificial intelligence and machine learning. I haven't seen other presentations today, so you may have heard different things. My intent today is not to stand up in front of you and establish a standard for what AI is. It's just to kind of get on the same page, so that when I say something about AI, you kind of know, what I'm referring to, or machine learning. We just kind of have that common understanding. And so this map, think of this as a partial map of all the things that can fall under the umbrella of artificial intelligence. The areas that you see here are ones that I operate in, and my folks, usually help others in. And so the first at the top left is machine learning. And I would label this traditional machine learning. So this is when you have a lot of data, it can be in a database, it can even be harvested from spreadsheets, and it comes in and you are, rather than have a type of, say, rules-based system, so if you want to figure out like, hey, here's valuable customers and here are less valuable customers, instead of, saying, hey, if they spend more than $10, valuable, if they spend less than $10, not valuable, you have an algorithm you program into the computer to kind of iterate over, and you just tell it, you just say, hey, here's a list of 1,000 customers, we think these ones are valuable, these ones aren't, and then this algorithm can work and iterate over and determine for each new customer who is valuable and not. So that's machine learning. You may know, more on that. It can actually be applied in these other areas, so we can apply it to speech, to vision, to NLP. But overall, what I'm trying to say is that, hey, we're going to talk about tips and tricks and good things to know for machine learning and for those components of speech and vision and natural language processing. When you get into some of these other things, like robotics, then you start bringing hardware into the equation. Certainly some of the principles that I'll talk about here can be used, but I'm not speaking directly to that. Glad to have that discussion afterward. Okay, so when I work with companies, I often hear these types of questions, and the first one is is almost always the case. Where should we focus our initial AI effort? Right. So resource management is always an issue with companies, and I'll talk about some things there. Right. The second question that usually comes up, and sometimes even before the first, is with data. And so there's two sides to it. One is, we have all this data, we're not sure what to do with it. Or, hey, we're using our data for some great things, what else can we do with it? Okay, and so there's some lessons there. And then on the flip side, companies say we just don't have enough data. We're a small outfit, we have, a couple dozen customers, we don't collect a lot of data. Can we even use machine learning? Is there any application of AI? Well, there usually is, or there sometimes is, and so we'll talk about that. And then finally, we'll talk a little bit about gaining traction with decision makers, where, in any effort, anytime you're trying to improve something, change something, operating from a functional perspective, you'll be able to, show all these great things, and then you'll ask people to make decisions, change the way you operate, put information out to customers, collect data differently from customers, etc. And those efforts are, they can be met with different perspectives. As far like, yes, go ahead, or no, let's wait and see. And so we'll talk a little bit about communication influence. All right? So the first thing we'll talk about is how to focus the efforts. And this is a case study from the NFL. I was able to work with the NFL earlier this year on a pretty interesting project. And I use the term here, picking projects deliberately. Because what we found is that when you have something that's well scoped and more at a project level, that will help get things started. So very often companies try to start at a high level. They want to develop an AI strategy. They want to develop this whole roadmap. Those things are great, believe me. I like those things, I think we all do, and they're very useful. But sometimes they also get in the way of starting. Okay, and so here's an example here. The NFL actually has a data analytics group, and they've been operating for some time. But in this case, it was the health and safety group that wanted to jump in, and they wanted to use it for a specific purpose. And the way they got there was, they have an issue with concussions. You may have heard that this has become pretty prevalent in professional football, and Keith was telling me that it's also become an issue in college level football. And so they've been tracking these numbers, and initially in the NFL, had a sort of opinion that you might expect, where they sort of circled the wagons and said, no, we don't know what you're talking about. Well, that didn't really work out too well. As you see in 2015, they spiked and they stayed pretty high until last year. They've come down a bit. It'll be interesting to see what happened this year. Okay. Well, the real issue here is that the NFL, the players, everybody involved wants to reduce the risk of CTE, chronic traumatic encephalopathy, I think is how it's pronounced. Basically, long-lasting brain injury. Right, so it's not the concussion per se that is terrible. Maybe you've had a concussion. I know that I've had one or two that I know about, and as far as I know, I still function as normally as I otherwise would in daily life. The problem is when you get the repeated concussions, the severe concussions, and then you get this. So imagine if the NFL had come out and say, okay, data scientists, we want you to reduce the risk of CTE in our players. So where do you start with that, right? There's all sorts of things. You have technology, you have all these different things. So they started working this down from CTE, and they started doing some scope reduction, right? And they said, well, from CTE, certainly we want to control what we can, which is the occurrence of concussions. And they have a severity issue. And then they said, you know what, we want to focus specifically on punt plays. So the previous year, they had focused on kickoffs. And if you follow football or have read, then you would know that there were some rules changed in terms of kickoffs and returns and where to place the ball after a touchback. They placed some rules on head-first tackles, and these things, seemingly had an impact. But they felt that punt plays were still dangerous. And there's a whole lot of reasons, but there's basically just a very chaotic scene that occurs when the ball is caught, where players are coming in at different times and angles, and it's fairly dangerous in terms of risk of injury per play. In fact, twice as risky as a running or pass play. Well, then they scoped it even further, and they said, you know what, we're going to scope this down to rule changes. And so the goal of our project from an AI perspective is to reduce concussions on punt plays by changing the game rules. Okay? And then they released all this data that had to do with punts and injuries. And so now you have like something you can work on. All right? So they were able to release all this data, who received the injuries, what they were doing. They do a lot of really cool data collection now, where they have the players wear sensors. And so every player on the field has a sensor mounted on the uniform, and it records 10 times per second the position, the orientation, the speed, all of these different things that you can get from a GPS type sensor. And so they're able to amass all sorts of data. They released it. I was able to have a look at it just for the punts alone over 2 seasons. It was millions and millions of records, and able to sift through that with the help of some other people. And we found out, for instance, that a lot of those concussions occurred from a player getting blocked. So it wasn't the punt returner getting tackled. It wasn't a player making a head first tackle, doing the tackling, although that is also important. It was a player getting blocked, and it was mostly, or at least over half, due to blindside blocks. So we made a recommendation, and this was mine, to penalize blindside blocks, including any forcible contact of a player. So prior to that, there were some cases yes, some cases no, and guess what? They actually were able to get a rule change this year. So if you've been watching the season so far, or if you go and watch a game now, they were able to get that rule passed, presented to the owners, and so now blindside blocks will be called on punts. Some fans are not happy about that because they like the violence and they like that whole thing, but definitely better for the players, and it was fun to have a part of that. So the lesson there is, scope those projects down, and do that with input from the business. Don't try to dump it onto an analytics group or a data science group and ask them to scope it down. Sometimes they can do that, they have the capability, but they really need to work with the business and prioritize. The other secondary lesson, not really shown here, is share your data. Right? Don't circle the wagons and hide, get help and ask for help. So by doing those 2 things, they were able to do it, make some great progress. All right, so another good practice is sharing data. So whether you have all the data you need and don't know what to do with it, or whether you need more data, sharing data can create its own value. And so I have companies ask me quite a bit, hey, we don't really have a machine learning project per se, we want to have one, but how do we monetize our data, right? That's the big term. And here we have this is from a 911 call center. And so I worked with a 911 group, and they're an enhanced 911 service provider. And so it turns out that if you call one of these emergency centers from your cell phone, from your mobile device, they might not know where you are except to the nearest cell phone tower. Okay, it's like, wow, that's not very good. If you call from your home, of course, they know exactly where you are. If you call from a cell phone, especially say 10 years ago, even 5 years ago, and it sometimes happens today, they're not going to have a very good idea where to send people. So, public service announcement, make sure you tell them where you are before you hang up the phone or what have you. Now, what this company does, the Enhanced 911 company, is they help that get better. They use the GPS in your smartphone. They use any Wi-Fi networks that you might be connected to so that they can grab an IP address, and they run that through some servers and through some other services, and they get back a more precise location, sometimes within 10 meters. And so even if you're out in the middle of a field somewhere or in a building on the 3rd floor, they can start to pinpoint where you are. And so you can imagine here, all these different call centers are benefiting from that. And here's a diagram of how that kind of works. And it really is not important exactly how the data flows, but the point is that they're sharing. Okay, and so the first thing that they're doing is that they're sharing data across their customers. All right, and this is one of the biggest things that I find not every company can do, but a lot of companies. Because if you think about what your company does, whatever product or service you provide, you're very likely your customer's sole supplier of that thing. Maybe they have a couple or even 3, but for the most part, whatever they're buying from you, they just buy from you at this point in time. And so that's all they know. On the other hand, you have dozens or hundreds or even thousands of customers. So you see a lot of those transactions, and you see a lot of data coming back and going. And so one thing that's just really great for customers to know is, hey, how do we compare to others? How would you see, what we produce? How do you find our data exchange? How do you find the prices we pay and the prices we charge? In a maintenance context, a lot of times the manufacturer, if your company manufactures something, you have inside knowledge to product failure because you see product failure across all your customers. You can share that data. And in this case, these emergency centers find it very valuable so that if you're in Cheyenne, Wyoming, you don't have a lot of points of comparison in your state or in your part of the country. It may not be easy to share data with Boise or Salt Lake City. I mean, maybe they do. I'm sure there is some degree of sharing in a consortium that they can belong to in an industry, but this company is in a great position to share. And so what the enhanced provider does is they share this data across, and they help benchmark. They help benchmark things like response times. They help benchmark accuracy, okay? And their customers have found that very useful. So I would say give that some thought, and maybe there's an opportunity there. All right, the other thing they do is they take data from suppliers and they mine that pretty intensely. So the data they get in this case is from the major carriers of the telephone system, and that local service will send their 911 data, they call it spill data, they'll send it through the company. And so all the enhanced company needs to do is they need to get certain data to their customers, to the emergency centers. But what they found is they can also serve a really good role by taking the data that customers don't need and finding out some more about that. So for instance, you see just in the Western US how much call data they control. And when you look across the country, again, they're getting millions of calls over even a month, but a couple of months for sure. And they can find things like class of service. So there are rules around what the suppliers, in this case, the carriers, are supposed to provide. And they get all that carrier data, and they can then turn around and they can go back to the carrier and say, hey, look, this government mandate is coming down in 3 years that says you have to have all your calls at level 2, phase 2. And we found that you're barely at 50%. You're supposed to be at 60, you're only at 50. I hope you have a plan. It's not really our business. We'll try to help you, but here's what the data says. And oh, by the way, here's how AT&T, you compare to Sprint, T-Mobile, and all those things. All right, so they're going up the supply chain as well, and they're providing insight to their supplier, all right, the supplier of data. So you might have an opportunity to do that as well. You can also connect them to their customers. Okay? And so the last thing they're doing is that they're actually going to the end of the value chain, to call it the point of use, which is where the first responder is interfacing with the end customer, which is the person with the emergency. And they're getting data there, not only response data, but they're getting call outcomes, and they're starting to record all of that, which in one sense, might seem a bit scary, but so far it's being used for good purposes. And then they're providing data back to these emergency teams. So they have the ability now, if you've ever seen the movie Minority Report with Tom Cruise and the pre-crime division, yeah, okay, this is getting strangely like that. Because what they're able to do, and in a good way, what they're able to do is they're able to look across all this data, get some exchange from the emergency folks, and then they can come back and they can say, oh, hey, by the way, let's say in Las Vegas on Friday night at 8 p.m. in these types of environments when the weather's over 100 degrees, I mean, whatever you want to come up with, you should be staffing with firefighters and police in this vicinity. And so some of those things the local police can already figure out. They know sort of when the crime is going to occur. But in some cases, those trends might not be obvious. And so they're helping to do that and actually pre-position emergency resources. And not just for crimes, but for car wrecks and things like that. Medical emergencies, if they can bring any sort of health data, then they can start using that. So sharing data is a great thing. Companies are sometimes hesitant to do that for proprietary reasons. You don't want your competitors always knowing what you're up to. Your customer or your supplier might share that with somebody else. But a best practice that's certainly emerging and has proven well is to share that data, write it into your contract so that you can protect everybody, anonymize it as much as you need to, and benefit. It's usually going to help your product and help your customers. All right. And then the third part is around communication. So this is true with anything. I found it to be doubly so with machine learning. Because machine learning has all the mystique. It's a lot of heavy math. There are some things that it's hard for people to understand how code is doing this and processing it. Back in the good old days, you could write some equations and explain them, and hey, there you have it. Okay, this is a little more complex than that. And so here's a story about when I was working with a litigation team. And so this is when I did some expert witnessing. And I found this example to be very helpful in working with companies, especially if you're just starting with machine learning and putting models out there for decision makers and other folks from a business to see. And the first thing is, use familiar inputs. So if you were to build a model based on these factors, I think most folks in business can understand these things, right? It's just total sales, and it's your average sale amount, certain things like that. You can use customer counts and all these things. Machine learning is very remarkable in that even if we are only dealing with these 6 factors, we can get a more accurate model by combining them in all sorts of ways. Okay, so we can multiply them all out by each other, we can divide them, we can add them, take combinations of 3. There is no end to the amount of signal. We talk about getting signal from the noise. There's almost no limit to the incremental amount of signal you can get from just 6 variables. But then think about when you're trying to explain to a jury or a business team or your boss, well, hey, yeah, our most important factor was average sale amount divided by out-of-county sales minus repeat customer sales. And you go, what is that? Like, why does that work? Well, I don't know, it just does, right? And so machine learning is that way to an extent, right? A lot of times your best factors, like, you don't know why they work. It's correlation, not causation, okay? But people like to be able to understand what that model's telling them. So use familiar inputs, try to stick with them, even if you lose just a little bit of accuracy in your model. It probably will be okay, probably will be. All right, and then the other part is to try to use explainable concepts. And so if you read about deep learning and neural networks, those have gained a lot of attention lately. Very powerful technique. It's very different from what you might call a traditional machine learning algorithm. It's meant to function very much like a human brain, and the way neurons fire in a chain in the human brain. The problem with it is kind of like the brain, it's really hard to explain how you take a bunch of pixels as ones and zeros and get a computer program to recognize that that's a picture of a dog and not a cat. And as you try to peer into it, you start seeing fuzzy shapes, and it's really hard to explain. How does it work? I don't know. How does a 3-year-old know that it's a dog versus a cat? He or she just does, right? So there's a lot of work being done in this area, and it's still behind. So one of the things you can do is, not use the black box, use a more explainable concept. It's still going to be difficult. And so then your challenge is to try to find an analogy that might work. And so here's an example here. This is a thing that we used, and it's called, the technique is called teasney. So just to set the stage, this case was about trying to find some stores that were committing, we'll say in layman's terms, they were committing fraud for a public assistance program. So the stores were basically accepting vouchers from people for nice things like formula and healthy vegetables. And instead of giving them, say, $50 of formula and healthy vegetables, they would give them $10 cash. Or maybe give them some beer. There were different scenarios. And then they turn around and tell the state, hey, we just gave this person $50 of formula, so please reimburse us for $50. So you can see that's very profitable over time. And what we found is that you can use machine learning to start finding patterns in these transactions. Because the state had every transaction over the past year, and they had all of the different data. So you can start finding these transactions and the patterns in there. So we used a technique called teasney, which stands for T-distributed stochastic neighbor embedding. Right? So can you imagine getting up in front of a jury and say, yes, ladies and gentlemen, today I'm going to talk to you about T-distributed stochastic neighbor embedding. They're going to like, what? So all we did was say, hey, this is teasing. When we talked about how it worked, we didn't talk about multi-dimensional Euclidean distance and all of the crazy stuff that this thing uses. I mean, the math is really, really impressive. We said, hey, one way to think about it is like this. We're going to take representatives from all these stores, and we're going to put them in a room. And they're going to be able to ask questions about each other. They're going to ask about their total sales and their out-of-county sales, and some of these things you see on some of these factors on the left. And much like people do, they're going to start to sort of gravitate to other reps that are like them, and they might sort of kind of gravitate away from those that aren't like them. So, and this is not a very friendly, diverse group, right? They're all about like with like, and that is what this algorithm does. And so you imagine what happens is that all the Walmart folks start learning that, oh wow, you have $2 million in sales per day or whatever their store value is. Yeah, let's go over here and talk with other big stores. And so all those big stores gravitated up towards the top right of this, and smaller stores tended to be back down the lower left. And then as they all got up there, think about they all get up there, and then they start talking, and they say, well, how about your out-of-county sales? And they say, well, no, we don't have very many out-of-county sales. People usually go to the closest Walmart. And then one of the people with high sales says, oh, actually, most of my business is from out-of-county. Like, what? Okay, well, maybe you go talk to these other people in group 3, because you all have high volume, and you have out-of-county business, probably have a lot of things in common. Right? So they go over there, and they start talking about how to do better. And over time, all of these points sort of gravitate. And then, you have down in group 2, you have stores with low volume. They have super high growth, they have really high margins, maybe they only sell formula on Mondays because they're only open on Mondays. That's kind of weird. And it's all out of county or what have you. Okay, so that's how we explain this. We try to use analogies. Even talking about it can be confusing, so we went through scenarios of dumping a bunch of Lego blocks out on a table and just kind of sort them out by size and by shape, and so that people get an idea of what this is, and then they understand. Now, what happened was, when you do this, an interesting point is that the orange triangles of known bad actors is not in this algorithm at all. This is all done just at face value. So all you know are these 6 things, and the data will self-organize using this machine learning program. And then you light it up with where the known suspects are, and it's like, ding, ding, look at group 2. Like, that's hardly a coincidence that out of the 18 or so known suspects, so many of them, 14, 13, whatever the number is, are all in group 2. And how about these other stores in group 2? If we look at them a little more closely, things start looking suspicious as well. And so the argument was, the whole walks like a duck, talks like a duck, chances are they're up to something fishy here. All right? And so that's how that works. But the only way that was ever going to work is if we could design it in a way that people understood. So I had to take care of writing things in my report. We had to, as a team, think about how you communicate this. And you have to do the same things in your business. I know that myself, as a tech guy, I love to get up there and show really complex charts and all the gee whiz stuff that I've done, and so many times a bar chart just would have been much more effective with the audience and gotten the message the same way. So work with your data science teams, your analytics teams as well, help coach them on how to speak to folks. And that way you'll get traction with your group, and people will trust machine learning. Okay? And then the last piece, wrap up here. The last piece is, even when you do all this, there's going to be a limit to understanding, and it's only going to go so far. So my grandmother grew up in Siberia. She was born there and lived there for, I think, most of her youth. And so she might like this Russian proverb with apologies to native Russian speakers. It's "Dovoryai, no proveryai," all right, which you might know from its English translation, trust but verify. Okay? So politicians love to say trust but verify. It actually serves you pretty well here when you think about your own machine learning efforts or AI efforts. Allow other people to verify. That's often the best way to gain trust. Really, who really knows how electrical current flows through the silicon in a transistor in your computer? We just trust that it works. And we trust that it works because when I type in 1 + 1, the monitor says 2. Right? Same thing with machine learning. If you can show that this works and you say, hey, we're going to verify our results. Here's the data that you know. Here's a known outcome. Look how closely it matches. Let's do a pilot for the next week. And hey, look, we actually predicted sales better than any other system we have so far. So it's not perfect, but it's okay. People will start to trust the model once they can verify it, and then that'll work in tandem with the understanding to get you a sheet. Okay. All right, so with that, before we do questions, I think if there is one strategy that you can pursue that works, it's to, hey, start with basic principles like this and go from there. Start out with the fundamentals, focus projects, supplementing your data with outside sources, right? Share that data up and down the value chain, and design models for understanding that you can communicate. All right, so that's all for my presentation, and I think we have some time for questions now. Thank you.